first thing that you guys were going to do. Now, if you look at here are the instructions that I wanted you guys to follow. You're going to dilate each coordinate. Now, the coordinate that was given was D, 0, comma, -1. Is everybody able to take a look at that point right there? 0, comma, -1 right there? Yeah. Okay. The other coordinates that you should have found were C. The coordinates of C are 1, comma, -1. That's for C. For B, you got +1, comma, +1. And for A, I'm going to put it over here, 0, comma, 1. Before I do anything, I just want to give everybody a chance. Does everybody understand how to read the coordinates of a point on the X line? Yep. All right. When you guys do dilations of a scale factor, all you're doing with the images, you're enlarging or reducing it. And usually you guys do this when you guys take pictures. If you take a picture and you maybe want to make a wallet size of it, that's a dilation, you're shrinking it. You could also do a picture as a poster size. That's an enlargement. Yep. What we're going to work on today is finding out the coordinates of those images. Okay? So here's all you had to do. Multiply each coordinate by 4. Does everybody agree 0 times anything is 0? So the coordinates for A prime should have been 0, comma, 4. For C prime, they should have been 4, -4. Okay, stop me right there. Is everybody okay so far? Yep. Has that anything that seems too weird for you? No? Okay. And then B should have been 4, 4. All right, now does everybody, oops, that's B prime. Okay, does everybody see all, now you know all the coordinates of all the prime images? All you gotta do is plot them now. If you haven't plotted them, can you do so quickly? While I'm plotting the ones I'm gonna put up here. 0, -4, 0, comma 4, 4, comma, -4, and 4, comma 4. All right, did everybody see those green dots that I have plotted? Are you able to do that on your own? Yeah? Do me a favor, can you connect them with dashed lines, not solid lines? Make them as best as you can. If they don't show up, let's highlight it. If it doesn't show clearly, we're going to highlight them. Okay. So go ahead and highlight your new image. I passed out the highlighters. And does everybody see that image highlighted? Does everybody see the original image? Okay, do me a favor with your pencils. I want you to draw a line from the original coordinate to the prime coordinate. Now, I want you to notice something. You notice that the original A to A prime is still on the y-axis, so you're not going to be able to see that line. And the original D to D prime, make sure you guys are labeling all your transformation images. You notice that if you connect those 2 points, that line is still the y-axis. So with your pencils, it's not really going to be able to be distinguishable. Okay. But do you notice, can you guys connect C to C prime for me? And then go ahead and connect B to B prime. You guys start getting a three-dimensional view of something kind of being enlarged or shrunk right there? You see like a little window, maybe? Yeah. When we do dilations, and they tell you, dilate the image by a scale factor. If it's 1 or more, that dilation is going to make the image bigger. What do you think would happen if you do a dilation with a scale factor of a number that's less than 1 but bigger than 0? It's going to shrink. Okay. Have you guys ever played with images on your computer, enlarging them and shrinking them? Photoshop, stuff like that? Let me show you a few images that I'm going to play with right now. Not frozen, why not? I love frozen. That's bad. Frozen is cool. My daughter loves frozen. Alright, let's pick my theme here. 4 seasons. Everybody realize that the seasons are starting to change. You guys starting to notice that the trees, the leaves are starting to die out a little bit. We're going, we just finished summer. Now we're into fall. Okay? Once we get to fall, we'll get to winter pretty quickly. Yeah? And then after winter comes spring. Everything starts to look alive again. Green starts to get greener. Yeah? You notice I have my image of the first over there with the, I like trees. That's all I like trees. Alright. So, now, I want to take a look at this image, and I can go ahead and make it bigger. Now, you notice as I make it bigger, what do you start to see? The pixels. So, are you guys familiar with your cell phones or your cameras? The more megapixels, or the more pixels, I should say, that the camera has, do you think the image is clearer or not? Yeah? Who can describe what does pixels mean, especially when you guys are on a TV, looking at a TV? What does it mean? Does anybody know? Small. Okay, good. Small individual screens. Can you see this image right now? Do you start to see some like square formations happening? Yeah? Especially, you notice right there is like a square, white square. You start putting all these little white squares and they make an image, yeah? When I go back and take the zoom off, it starts to look a little bit nicer, right? Yeah. But remember, as I opened it up, right now you can't tell where that square was anymore, right? When you look at a TV, the more pixels that TV has, the clearer the image. So when you were explaining kind of like the dots, it's kind of like the more squares it has, the more littler squares it has, the image is going to look even more amazing. Yeah? If you ever, has any of you ever seen the old video games? Oh, yeah. You saw the images look very squarish. I think some of the very first video games ever made, they were all very square images, and that's because when they were using the math to make those video games, they were working with 2 dimensions, or X and Y axis. And they were only working with the little boxes on the X and Y axis. But the more you make those boxes smaller, the images get a lot more definition. Yeah? If you noticed when I zoomed it in, you guys started to notice that the pixels on the image started to become more visible. So if I were to blow that up, Like I have my screen over there going up. Yeah. But if you go over there and look at it closely, you'll start to see the little squares because it's not, the pixels aren't that good. Had it been, the pixels been more pixels in the image, and when I blow it up, it would allow it look even more definition. Yeah. Can you see my dilation happening in that wall? Does everybody see the dilation happening in the wall? This is where it's called a bow window, where technically if this was real, I would be able to lay things in there and almost sit down there, but it's only oval, only a part of the window is oval. Yeah. But do you see the lining that's happening? And what I was trying to do was to make it look like there was depth in there. Yeah? Okay. We're going to get to a part where first we're going to learn about dilations a little bit. I think you guys kind of got the idea of it. I want you to, when we get to the next class, we're going to do some activities that involve some drawing. Okay? But we're going to first work with the simple method at first. Get the basic skills. Okay? Then we'll do some fun stuff. Okay? All right. So dilations, I can enlarge something or I can shrink that, right? And the pixels will change. Yeah? Okay. Let's go ahead and put my handout. All right. So everybody see the dilation for all these coordinates were based off of these points. Okay. Let's go ahead and go to the next. So as we finish that, the next part, these are step instructions on from C to C prime, yeah, and then from A to A prime and B to B prime. Okay. Let's go ahead and go right here. We're going to do a dilation of a scale factor of 1/4. The coordinates for the letters A, B, C, and D. So can everybody do me a favor? Go ahead and identify the coordinates of A, B, and C. And go ahead and put them over here on the left. Yeah. And this is the image that we're looking at right now. All right. Did everybody see where the x-axis is? And you guys identify the y-axis? Now, does everybody agree that the coordinates of A based off of that x and y-axis are 0, 1, 2, 3, 4, 5, 6, 7, 0, 7 for the A coordinate? Yeah? Okay. What about B? What did you guys get for that one? 4,3. And C would be 4,-1. Okay. Now when we multiply that by the scale factor of 1/4, just keep in mind 1/4 multiplied by the x, and then 1/4 multiplied by the y. So we're going to do this to each coordinate. So everybody, if you guys have trouble with multiplying by fractions, just remember the rules of adding and oops.
Oscar, I think I actually got B mixed up. I think it's 3,4.
Okay, we'll check it real quick. Thank you for reminding me. All right, can everybody check? 0, 7 was, everybody agreed on A was correct? Okay. B, let's check it again. 1, 2, 3, 4, 3. That one looks right. 4, 3, yeah? Yeah.
Oh, well, I'm getting all mixed up. Sorry, I'm tired.
Yeah. And C was 4, -1? Doesn't hurt to check. You guys see me, I make mistakes, so it never hurts to check. And don't be afraid to tell me if you're not sure, okay? All right. Now, does everybody see what I wrote up here? I'm going to multiply everything by 1/4. Since I'm multiplying by a fraction, the image is going to shrink, okay? It's less than 1. As long as the number is between 0 and less than 1, the image is going to shrink. If it's negative, then we're going to look at the changes. Yeah, anything that the 1 and above is going to make it bigger. The absolute value of that scale factor is greater than 1, it's still going to enlarge it, okay? And then you notice it says centered at 0,3. First, we're going to go ahead and dilate it just like you learned how to do it right now, okay? And then I'm going to talk to you about, well, what happens if we were to center it at 0,3? I'll show you. It's a very simple little trick, okay? All right, so does everybody agree that 1/4 times 0 is 0? And 1/4, and I'll do my side work here, 1/4 times 7. Now, does everybody understand that 7 is not written as a fraction? So what would be a good thing to put it? Put it over 1. And the reason why I want you to do this is because I want you to remember, adding and subtracting fractions, you have to get a common denominator, right? When you're multiplying fractions, or if this was a division of a fraction, I just change division to multiplication and flip the fraction to the right of it. When you guys are multiplying fractions, all you got to do is straight across tops and straight across bottoms. Yeah? Make sure that after you do multiply, can you reduce the top and the bottom? Okay? All right. Do you notice that when you multiply across, you'll just get 7/4? Yeah? Now, everybody on your calculators, can you do 7 divided by 4 real quick on the calculator? 1.75. Okay, so that's 0,1.75 as a decimal. Now I want you to think of it as money. That's $1.75, not $2, right? So when you plot the point, you're not going all the way to 2. You're going to a little bit less than 2, not to 1.5 though. Yes? All right. So everybody go ahead and plot A prime now to 0,1.75. You notice that 0,1.75, you guys understand that each little box is represented by 1 unit? All right. So 1.75, I'm going to use a different color, okay? 1.75 would just be below the 2, not right at the 2. Yep. And label that your A prime. 0,7/4. And everybody understood how we got the 1.75 right now? All right, go ahead and do the coordinates for B and C for me real quick, and then we'll check. Okay, so for the multiplication of 1/4 times 4, does everybody understand that 1/4, when you multiply it by 4, will give you a 4/4, which is 1. And then 3, when you multiply it by 1/4, will give you a 3/4. And 3 divided by 4 on your calculator should be what? 1.75. So that's really 1,0.75. Yeah? All right, so 1,0.75. All right, so 1,0.75, roughly about right there. All right, for C, 1/4 times 4 is 1, comma, And then 1/4 times -1 would be a negative 0.25. Now, do you see that that's a little piece of 1 whole unit? It's a quarter of the whole thing. 25 cents of a dollar is 1 out of 4 quarters, right? Yep. So go to 1, comma, negative 0.25. So don't go all the way in half, just go below. And now go ahead and connect that. And you see you got an image very small. Now I want you to take a look at something. Does everybody notice that the B's, when I connect them, because that's where B prime is, right? And A prime is right here when I connect them. And when I connect C here to C prime, you guys notice when I connect those points, where do they all intersect at? At X, comma, Y. What's that point called where X and Y meet? The origin. What are the coordinates of the origin? 0, 0. 0, 0. So right now, we have a dilation with a scale factor of 1/4, but we have it centered at the origin at 0, 0. They want us to center it at 0, 3. Okay? So if they want us to center it at 0, 3, and we'll do this on the next one though, okay? But I want you to understand, we just did a dilation, but the only thing that's off, it's not centered at 0, 3. It's centered on 0, 0. And here's how you check it. Connect your original image to your new prime image, and wherever those lines are intersecting, that's where the point of origin is, okay? We actually wanted the origin, really? They wanted us to do a center at 0, 3. Everybody agrees 0, 3 is right here? They wanted us to make this the origin. So that's where the x-axis was, and this is where the y-axis was. That means the coordinates of A prime then would really be at 1, 2, 3, 4. A would really be at 0, 4. B would really be at 4, 0. And C would really be at 4, 1, 2, 3. C would really be at 4, -4. Now, everybody, put your pencils down. This is really important, okay? Did everybody see the blue X and Y line that I made? Do you notice that the blue X line and the blue Y line meet at the coordinates 0, 3? That's where the center of origin, when they tell us that's where the center of origin is supposed to be, we have to rearrange the X and Y axis. Okay? And we can do this and get new coordinates and then go from there. Okay? Now, I don't want to add to it right now. I'll show you on the next one. Yeah? All right, so everybody go ahead and we're going to do a dilation with a scale factor of 2. So just do me a favor real quick. Dilation scale factor of 2. Is it going to enlarge or is it going to shrink? Enlarge. Okay. Do me a favor. Everybody go where 0, -1 is. And do me a favor. With your highlighters, put a dot there at 0, -1. All right, does everybody see where my dot is? We all get the same dot? So do me a favor. Draw a horizontal line through that dot and draw a vertical line through that dot. And that's where I want you to imagine that's where the origin is now. That's where the X and Y axis meet, yeah? So do me a favor. Get the coordinates of the dots, assuming that those highlighted lines are the origin now. Yes? Did everybody understand when I highlighted the coordinate 0, -1? That's where that point is. So from that point, I want you to draw a vertical and a horizontal line and a vertical line through it. And now pretend that's the origin. Yeah? So the coordinates for A then technically would be 0, 1. For B, they would be 1, 1. And for C, they would be 1, -1. Everybody with me right there? Okay. Stop me if I've gone too far, because right, this is going to be the part where you guys are going to get lost. Everybody okay with me highlighting a new origin now? Yeah? And the way I did it was based off of the new center of origin. Yeah? So now when you multiply this by a scale factor of 2, coordinates for A prime then are what? 0, 2. Everybody okay with that one right there? Yeah? Alright, coordinates for B prime would be 2, 2, 2. Okay, is everybody okay with that one right there? Yeah? Alright, and the coordinates for C prime would be 2, -2. Okay. Now remember, this is our new origin, the highlighted part. Okay, so let's go and place those dots. 0, 2 would be right there, and label it A prime. B prime is at 2, 2. And C prime is at 2, -2. And now go ahead and use dotted lines when you connect to those images. Now do me a favor. With your ruler, connect the C prime to the C image. Those 2 points connect and meet at the origin. At the origin of 0, -1. Check now, does B and B prime do that? And then A to A prime, if they all check at that point, then your dilation is correctly done. Okay? Any questions on that part right there? So when they tell you on the handout, dilate this, but dilate at a certain center coordinate, you guys realize you're going to go to that point and draw a new origin, and then go from there? Yep. Other than that, are there any questions then on what you're going to practice? You got a bunch of them that you're going to work on. I have the handout when you're finished. You'll just check your answers, see if they match. Okay? And then once you're done with that, we're done for the day. There is one part that I wanted to tell you about, and just let me go to it real quick here. You guys are going to do all these today right now, so you're going to practice all those scale factors. Okay? When you get to the following page, and it'll say, okay, here we go. Go to this page right here. And these are saying determine whether the dilation from figure A to figure B is a reduction or an enlargement, and then find the values of the variables. So very important what you're going to do here is you're going from figure A to figure B. So everybody do me a favor, highlight figure A. Okay, so from figure A to figure B, is that an enlargement or a reduction? Reduction. So go ahead and label it reduction. All right. Is everybody okay on how we figured out if it was an enlargement or reduction? Highlight only the figure A images, okay? Go ahead and highlight a number 6, the figure A image. Go ahead and highlight number 7, the figure A image. And for number 8, highlight the figure A image. And you guys understand, you're going to figure out from the figure A to the figure B, is it an enlargement or a reduction? Is everybody okay? You're going to figure that out? You're going to name it, but then here's the next part, okay? The next part is, it says find the values of the variables that are missing. So I want you to remember something. You guys remember when we were first starting this class, when we started doing transformations? Yeah? Do you see which side corresponds to side that measures 3 on the reduction image? Which side corresponds to the side that measures 3? What's it labeled? Everybody agree x and 3 correspond to each other? That means x over 3 is equal to, now you need to pick 2 aside from the original image that corresponds to aside from the reduction image, but they both have a value given. You don't want to get another pair that has a variable in it. 3 and z. Now if you pick 3 and z, those do correspond with each other. The only problem was going to be is there's 2 variables going to be in that equation we're setting up. So we don't want to set it up with another variable. 6 and 2, you guys agree correspond with each other? You notice I'm doing I wrote the small side over the big side. I have to do small over big on the other one as well. So that means I have to do x over 3 equal to what on the others? What should I say equal to? Here's 2 over 6. Does everybody see that the 2 is on the smaller image? And it corresponds to the 6, which is on the bigger image? Can anybody tell me how to solve this ratio of proportions? Does anybody know? Not cross cancel. There's an equal sign here, so it will cross multiply. Yeah, that's a 6 here, not a b. Okay. If you set up 2 ratios with variables on both sides, the only problem that you're going to get stuck with is you need to have 3 out of the 4 parts of the ratios. Okay. You notice that 6 is going to multiply with x. That'll give me a 6x equal to 3 times 2 is 6. Divide by 6 to solve for x. X equal to 1. Did we finish all of them? No. Tell me, what do you know about rectangles?
There's 2 sets. Two sets of equal sides.
2 sets of equal sides, and they're always opposites of each other, right? If x is opposite z, does everybody agree that? Therefore, x is equal to z, isn't it? By the rule of rectangles? If x is 1, what's z then? Z is also then 1. What does y equal then? Y is equal to 2. You guys agree opposite sides of a rectangle are always equal? Yep. Now, when you guys get to number 6 and 8, those triangles, make sure you set them up so that you set up the sides proportional to each other. Okay? All right. Other than that, the rest of those problems right there should be fairly simple. If you get stuck on any of them, we'll just have to check your answers. Now, I'm going to put the answer sheet over here on this table. It's to check your answers, not to cheat your copy paste. All right, so does everybody know what you're working on then? Yeah. I have the answer keys on the table, so you can check your answers. They're labeled with each page, dilation A, dilation B, C, all the way up through J. So those images, make sure your images are correct. And then last page, this one right here, let me see that one when you're finished. And that's all for today, okay? The music I play, if you're louder than my music, then you need to keep your voices down, okay? So make sure that you guys are not louder than my music. Hmm.